So in the previous two examples, we looked at the more usual case. We had two answers for each. We just left one in radical or exact form, and we left the other one in decimal form. We'll look at three more examples where our answers are a little bit more unusual, but we'll tackle them exactly the same way. So looking at my equation, once again, it is quadratic. The highest power that x is raised to is 2. It's already set to 0, so that means I can read off the values for a, b, and c directly. A is equal to 1, b is equal to -8, and c is equal to -33. Filling in the quadratic formula gives me x is equal to negative times -8 plus or minus the square root of -8, again in brackets here, all squared, minus 4 times 1 for A and -33 for C. All of that is divided by 2 times A, or 2 times 1. All right, so x is equal to +8 plus or minus the square root of 64 plus 132. And all of that is divided by 2. In other words, x is equal to 8 plus or minus the square root of 64 plus 132 is 196, all divided by 2. What makes this question a bit unusual is that 196 is a perfect square. In other words, x is equal to 8 plus or minus 14. And all of that is divided by 2. So x is equal to 8 plus 14 divided by 2, or x is equal to 8 minus 14 divided by 2. 8 plus 14, all divided by 2, gives us 11, and 8 minus 14 divided by 2 is equal to -3. So our answers are rational numbers. In fact, they're integers. And recall that a rational number is just a number that can be written as a fraction where both the numerator and the denominator are integers. So all integers themselves are also rational numbers. All right, every time that we have rational numbers as answers, it means we could have factored the original question. If we look a little bit more carefully at the original x squared minus 8x minus 33, maybe you've realized that you could have written this as x minus 11 and x plus 3 equal to 0. So either x minus 11 being equal to 0 would provide us with a solution, or x plus 3 being equal to 0 would provide us with a solution. So x is either equal to 11 or x is equal to -3. So here x would have been a faster way to come up with the answer rather than using the quadratic formula. How do we recognize when this situation is true? Well, we'll always get a rational answer when we have a perfect square under the radical sign. So if you evaluate just the b squared minus 4ac portion and find that b squared minus 4ac is a perfect square, it means you could have factored the question, or you can factor the question before going ahead and using the quadratic formula. It's up to you. In this example, I noticed that I again need to leave the answer in exact form, so I won't be reaching for my calculator in this one either. Looking at the equation, 16x squared plus 40x minus 25, the first thing that strikes me is that this isn't set to 0. So I'm going to have to move this -25 over to the left. We do that by adding 25 to both sides. So we have 16x squared plus 40x plus 25 equals 0. Now we can list the values for a, b, and c. A is equal to 16, b is equal to 40, and c is equal to +25. We'll take those values and plug them into the quadratic formula. So we have -b, -40, plus or minus the square root of 40 squared, minus 4 times 16 times 25. All of that is divided by 2 times 16. We have -40 plus or minus the square root of 40 squared, 1600, minus 4 times 16 times 25, also 1600, all divided by 2 times 16, or 32. So x is equal to negative 40 plus or minus 1600 minus 1600, or plus or minus the square root of 0. And what is the square root of 0? Just 0. So we have negative 40 plus or minus 0 over 32. We're rewritten over here. X is equal to negative 40 plus or minus 0, all divided by 32. So just negative 40 over 32. Or, because negative 40 over 32 can be simplified, we should write this as negative 5 over 4. So in this case, it looks like we have only one answer, negative 5 over 4. But the rule is that when we have a quadratic, when the highest power that x is raised to is 2 in our equation, we have two solutions. So what we report in this case is that x is equal to negative 5 over 4, comma, or negative 5 over 4. Our two answers happen to have the same value, but in recognition that this is an answer for a quadratic equation, we're going to write that same value twice. We'll explore what this looks like in graphing, why we sometimes have a quadratic equation that doesn't have two distinct, two unique answers. And just one more. Again, the answer will be in exact form. Luckily, in this case, we're already given an equation that's set to 0. A is equal to 2, B is equal to negative 3, and C is equal to 37. Filling in the quadratic gives us negative times negative 3 plus or minus the square root of negative 3, all squared. Again, we'll have brackets around that negative 3 to make sure that we get positive 9 out of that. Because all of b is squared again, not part of b, all of b, which includes the negative. In any case, minus 4 times a times c. All of that is divided by 2 times a, or 2 times 2. So x is equal to minus negative 3 or positive 3 plus or minus the square root of 9 minus 45. All of that divided by 4. So x is equal to 3 plus or minus the square root of negative 36, all divided by 4. Now that should worry you a little bit. If you reach for your calculator to find the square root of negative 36, it'll give you an error message. You can't take the square root of a negative number. It's an even order of a radical, so we can't have a negative number as a radicand. So this is not a real number, and therefore the entire solution is imaginary. The solution is an imaginary or complex number. So there is no value in the real number system that we can give here. So our answer just sits as the square root of negative 36. We don't need to do anything else with it. We might note that the answer is not a real number, but this is now our final answer.